Good morning, everybody. Just drinking coffee. Pretty much on time. I'm 7:48. Doing good this morning. It's July 10th, and it's Wednesday. Lots of stuff going on here in my place. New projects coming up every day. The list just keeps getting longer. Wanted to talk about charging batteries, Bedini style, and we're going to focus on the run side, which I call the voltage side or the high voltage side. And there's some interesting things that most people don't see just with the Bedini and possibilities of how that works. And so I've done some of my fancy drawing. I'm not a very good artist, so bear with me, but I'll try to make it all match up and make it make sense to you as we're going through today's program. Don't have too many followers on this channel yet. But I think people will find that after you get through my long-winded things, that I have a lot to offer as far as teaching what's going on and why I like the Bedini circuit, why I love the transistor. The transistors are just the neatest thing since sliced bread. They truly are. And you have amplification transistors that they can amplify up to 1,000 times. One of the questions that was brought up to me yesterday was about the Darlington. I'm not going to go into the Darlington transistor. I'm going to do that tomorrow in tomorrow's episode and explain how the Darlington transistors work. But today, just want you to focus on a Bifilar Bedini coil. Okay. Now, this Bifilar was wound on an electric drill, and it was started right here on this side right here. Okay. And it was turning on the electric drill clockwise. Okay. And so the start was on this side, and that way the top of it, you could run it back and forth. And I really don't remember how many layers this is. I think it's like 6 or 7 layers. I'm getting more specific in my layering. This was lynch style wrapped, which if you can find John Bedini and crew when they were making up a 7-filar coil with a trigger, it was made to that, except this is a bifilar. It just has 2. It has a trigger winding and a run winding. Okay. The run winding is the side that we're going to talk about today, and why did they run 7, 8, 9? Well, like I said, they ran 7 run windings and 1 trigger winding, and so the whole idea is this is oscillation, and I'm going to try to explain what's happening in that oscillation. You do have AC current depending on where you ground, okay, when the unit starts oscillating. You also have DC taps that have a DC potential, and I'm going to try to explain why you have that in testing and research and everything. So it's going to be a different episode. I wish I had all the tools. I wish I had my understanding of how to post things off my computer up where people can see it and see it in the background. So sit back, get yourself a cup of coffee, and thank you for coming to visit my channel. Like I said, I'm not trying to promote or sell anything. I am trying to teach about this energy that I found. I call it metronomic energy ultimately, and but you have to have the basics to get there. And like I said, I do have proprietary things that I am working on that are not for sale. Okay, actually they'll be licensed. Okay, and it's intellectual property, but it came from this. And if you follow this channel, you'll be able to see what I'm doing, do your own experiments, and figure it out. Okay. I'm still believe in the old adage that you can't get something for nothing. Okay. But you can have amplification. And once you know the I call it the tricks of the trade. Okay. It's not a magic trick, but it's understanding what's going on. It deals with parametric oscillation and getting hooked up to the environment correctly. Okay, the sun is what gives us all the energy. Okay, the heating and cooling and everything comes from that wonderful transformer that you see in the sky, I see in the sky here in our world. And so you have to make this stuff up. What I mean by make it up, whether you use spark gaps, or whether you use transistors, or whether you use vacuum tubes, commutators, it all boils down to the same energies, and it's very interesting. So anyway, like I said, if I'd have known what I know now about electric motors and the asymmetrical system, which is an unbalanced motor. Okay, the unbalanced motor, I call it a constant amperage motor, because once you build it to handle the amps, and the amps are pretty much controlled by your ohms, the amperage line stays constant. The only thing that changes within the system is the transforming in the motor itself to bring up a high voltage potential. And when you return that high voltage potential from your input side to the output side, and you can return that back to the battery post, electricity wants to find its shortest path, and it does that through the motor, and that's where the horsepower comes from. And one thing that I tell people over and over and over again, if you really want 1 horsepower, it's 750 watts. And my finding is putting it on the dyno is pretty much accurate. So the 1 horsepower, 750 watts, 10 horsepower, 7,500 watts. Okay. And so if you have a unit design to pull 10 amps, and you have to design the wiring that way, you design it to pull 10 amps. Okay. So if you're at 7,500 watts, divide that by 10, you've got 750 volts to make 1 horsepower. Okay. 10 horsepower. And there's no magic trick about it. That side of it is consumptive. However, we can get our Qs way up higher than most people realize. So, as I demonstrate the various devices, just understand that it's not free energy. It's the system does return the energy Over time, however, the system can rejuvenate itself. So if you have that much output coming through in the battery is still going to give up energy. You can return some of that energy to the battery while it's charging, but it's really best if you keep two separate states. So anyway, we're going to jump into it after that long-winded thing. Again, greetings and welcome. Thank you for coming to my channel, spending time with me. And get your cup of coffee and sit back and relax. Okay. I like to work with drawings, some kind of crude drawing to give me an idea of what's going on. And so before I started this presentation, I drew up battery configuration, okay? And you'll see there that you have your run side and you have your charging side. And today we're just going to talk about the charging side, okay, and how that works in the demarcation line, okay. And the charging side, because of the potential amperage, you'll notice that I have one side that has potentials in series. So you have a 12 volt, but is it 12 volt? Okay, and I'll show you what I'm talking about that in the next episode. But you have your high voltage side that's wired in series. That's this side right here. And then you have your parallel side. That's this side right here. And I call this the amperage size. That's the reason you need bigger wire when you start delivering the higher amperage. Now, one thing that people have tried to clue us in on is that there's a demarcation line that can happen between this charge side, okay, and the run side, and it's like an one more line there. So when you talk about 24 volts, 36 volts, how that all works, and this is the line of demarcation right here. You have your plus and you have your minus. I might be saying that backwards because I'm looking at it on the screen as backwards, okay? Now, this is the representation of the bifilar coil. We're just talking about the charging circuit, okay? And we're talking about the collector side of this circuit coming off of your transistor, okay? So I'm not drawing the connection from this collector over here, but you have this 2N007 fast switching diode that's in that charging circuit, and that comes right off the collector, okay? And so the pretty simple stuff. But one of the things that always got me when I was doing a Bedini, you have your plus and minus both off your bifilar coil, okay? So that's the bottom, okay? That's the start of the winding, okay? That's where the winding actually starts, okay? And it goes here to the demarcation line. Now, some people have wondered, why I made my original core like this. And in my vision, I call the south side the suction side, okay? And the south sucks, the north presses, okay? The north pushes, it's pressure. So it's kind of like the suction is going, and the north is going, okay? And that's been my easiest explanation in my own mind. And so I drew a green demarcation line in the center, okay? And on the very, very small level, I'm talking about when you get to Planck level, there's a bubble way down in there, and that bubble is vibrating, okay? And then when you bend this in a horseshoe and you lock it, that bubble stays vibrating, and yet in the U shape, it'll hold a bar to it, and it won't let it go. I mean, it's the PMH is an amazing thing, but even though this is straight, not in the U shape, it's still a form of PMH, and that little bubble that resonates in there in the core is a dimension that most people can't see. It's like electricity. You can't see it. You know it's there. You can feel it tingle when the voltage and amperage gets high enough, and then you can get electrical shock, electrocution, and everything. But anyway, that's my demarcation line, and it'll slide one side or the other just a little bit. But basically, as the core gets a memory, it learns to switch back and forth on a pretty good lever. Okay, and yes, you are doing that by induction, but that bubble is what we're talking about, and that's the reason I designed that piece like that, to show to myself and demonstrate what's going on with the PMH. So the amp side of your battery is the current, okay, and that's the suction side. And you'll notice that the charge side, okay, charge side of the battery, which is this is the charge side right here, okay, that's on the minus side. The run side is on the positive. So the positive is giving you pressure, okay, and you have suction coming to the charge side. And we'll get a little bit more detail on how a battery delivers current, and then we'll give as we reverse and charge that battery back up, now it's that way. But I call the plus the potential pressure side, okay? I call the minus the potential suction side, okay? So just I call north pressure, okay? I call south suction, okay? Just like you're breathing. So that's what you're doing, is you're making a breathing, high pressure, low pressure, falls right on the way, all the way through with refrigeration. I mean, we're getting really basic stuff, but I have to kind of go there to like I said, if I understand it, I can teach it. And if you understand that basics on that side. So when you really start winding this up for the potential, I have found that 15 amps for charging lead acid batteries is perfect, okay? And you carry that 15 amps through the system. So your 15 amp line, you're going to be at least 14 gauge wire, okay? So even though it's a coil that you're developing with 20 gauge wire, when you really start pushing the amperage potential and the right transistor and the balance of the system, I'll be recommending 12 gauge wire for your coil to handle that circuit, okay? So and then it gets down to simply winding it up, the induction and the resistance. So all that stuff is easy peasy stuff to people who work with electricity, but I just want to explain to you that even though we're representing it with 20 gauge wire in the Bedini coil. It's actually a 15 amp potential charging system. And the all you're doing is running the system to where the batteries are oscillating with each other, and you get a charge. And then there's other things that I'll be talking about later as far as grounding and antennas that you can do in the system to get your runtime much higher than what it is. But just understand that the mechanical oscillator or coil oscillation, it all works the same way and it has the same impact. And that's the reason that when you're talking to different people, I need the neodymium 52 gauge magnets. And well, you might if you're really trying to make a real powerful monopole motor running other devices. Okay. In my situation, I found that regular magnets work the same way. Yesterday, we touched on the telemetry. Everybody gets stuck on round coils. Okay. But the other things happen when I was, if you didn't watch yesterday's video about where I took the protractor and explained the telemetry of laying it out in degrees and not just the inches, that it means something. Okay, so the shortest way to the path, and I call that a bisector, is 45 degrees. Okay. Now, one of the things that confuses people is I do use 120 degrees because that's the basis of three-phase energy. Okay. And I'm going to demonstrate in the future how to build a three-phase machine instead of just a single-phase machine. And that's where the three magnets come in. So basically it's a gear ratio that I'm working with, that every time my wheel goes around once, the compass goes around 3 times. Okay. And that's just because they have 3 magnets on there in the pulses. I've worked a little bit. One of the things when I started getting the speaker hooked up to it, I was expecting to hear the south make a different sound than the north. Okay. And I know it should be there, but it's not. There are some RPM changes and other things when I've run 2 south poles and a north. I've run 2 north and a south. I run them all south. But my instinct tells me, I can't prove that part of it yet and hadn't put it down on paper, that the reason you face the north out is because you're wanting to push pressure into your inductor, okay, and create a suction. So the ultimately to get just a little advantage, it's an asymmetrical system. Okay, the way that most people demonstrate this, yes, you can get your unit to charge and charge off the other batteries, and there's something that happens there that it appears that if you have a good set of healthy batteries, that you can run one set down and charge it with the other with the jewel thief type technology. So the where that energy comes from, nobody knows, but it's there. It just when you hook meters and things up to it, it disappears on you. But parametric oscillation is a real thing, and when it happens, there's things that it pulls from the environment that does give you an extra Q factor. We're talking about the guitar string, okay, and signal generation and modulation within that signal generation. And one of the things that I've learned through the Bedini circuit is that it's one hell of an oscillator, and I can have several oscillations happening just with resistance off the same thing, and only draw not even a watt of current to create all those different oscillations and harmonics, and I can do that on the same line and get some advantages there. So my goal is a 6-hour run time on a set of batteries, okay, to before unusable depletion. So that's my attitude. That's the way I'm taking it. You know, yes, you can get extended Q service, but as far as getting something for nothing, well, I've never really seen that demonstrated yet, but you can get incredibly long time. You can use the environment to get the system going with charging batteries. So we're just going to keep it very basic. Like I said today, is understand that all you're doing is taking a demarcation line. Okay, and that demarcation line is your neutral. It doesn't really care if you got amperage. It doesn't really care if you got voltage, and that's the beginning of your run winding. Okay, so that's all we're talking about is the run winding side of the unit, and coming back to the collector. And that's the reason that has to be a bigger wire. It has to be designed to carry the amperage that you're wanting to put through the system. And so ultimately be a minimum of 14 gauge copper wire, and I'll be building mine with 12 gauge copper wire. So that's all you're doing is sending 15 amps to these batteries in parallel. Now, and you have the potential off that to receive it. So this is the demarcation line of the batteries, and this is the demarcation line to the coil. And it's just a reflection, okay? You have in and out. This diode is here to switch the potential, okay? And the 2N007 is what's recommended at that point. So I'm going to try to hold this up here and help you see what's going on, and just on a straight coil, okay? This is the trigger, which is 24 gauge on this particular old coil that I've been using, demonstrating for a very long time, just charging batteries, desulfating them. And this is the start winding. Now, one of the things that I love about the yellow line, okay, just for color coding, that means that can go either way, okay? They can be, I treat yellow as if it's AC. So I know that this is the AC side of my run winding, okay? And so that run winding is what connects right there, okay? Because it's plus, minus, and that's the demarcation line, just like this is a demarcation line. So it's a neutral, but it has a positive potential at one time, and it has a negative potential at one time that goes through that same charging line circuit, okay? So hope that part makes sense, all right? So that's the bottom, turn it over, that's the bottom of my run coil, all right? That's all that is, all right? Now, the top of my run coil, that's the one that connects directly to the collector, okay? And the diode that I have right there is this diode right here on the end of my alligator clip, okay? And so all that's happening with my transistor, and when you have the big end up, it's backwards. If you have the small end down, left to right, it says eat, so that's your emitter, big base cookie, and that's your cookie, okay? When you flip it over like this, it's backwards, so your emitter is on the other side, okay? You follow me? Because on that's higher than there. So what we're going to do is we're going to hook on the charge winding side. We're going to hook you don't have to worry about this point, about the eat big cookie or reversed if it's upside down. All we're going to do is hook that to the collector. All right. And that is the charge, the run side, but it's also the charge side of that circuit, because actually the charge side of the circuit is past this diode. Okay. So we'll get into that, but that's what you're doing is you have the diode at the tail end, but that's actually your run circuit. And so your collector is both positive and negative potential. Okay, and it's pulsating back and forth. So we're just going to stop it right there on the charge circuit, why it's done that way. It's been 31 minutes. I hope you enjoyed this episode. Leave your comments. Subscribe to me if you're interested. I'm getting friends that all over the country that's interested in this technology. I started this channel because I like to renew old things. Okay, and that's my handle, Renew You. My name is Bill. I reside in Irving, Texas. I'm a countrified city boy. I was raised in the city. In 1985, went to the farm in Laneville, Texas, and learned to farm and ranch and do other things, and love horses. Cutting horses is my favorite. And the working in rural communities, I worked with a lot of old timers through the years, and I learned some pretty cool stuff that they did back in the day. And it's really a history lesson when you get into how the whole thing works and how everybody gets a job and does working. But be sure to, any information that you learn, pass it on to others, explain what's going on. This technology is going to be the coming thing. I see very quickly that people are going to be using electric cars a lot more, and they'll actually be much better than the combustion engine. So I love two-stroke motor. I love the way they sound. I love motorcycles, love airplanes, love boats. But man, the silent power that's available through electric motor and electric generation is going to be the way. Will we be using solars? Yes, we'll still be using solar. We'll be using wind power? Yes, we'll be using wind power. And as we learn to harness those energies with our environment, we're going to learn a whole lot more. The problem with the big wind farms is they kill birds. Okay, that's the problem with it. And they work on a great big scale. On the demand side of the energy grid, I understand that they have huge flywheels. They spin up really fast off of that and can deliver lots of generation when they need high demand. So they collect it through the day, and there's some loss there, but it's worth it. It's worth to it off the wind farm. So we're just getting tapped into working with our home environment. Have no big pie in the sky of being ever completely off the grid. However, for emergency generation for a short period of time, there are some tricks of the trade that you can get extended run times, and that's what I'm after. And so you guys have a blessed day. Work hard, share with others, pray for each other, love each other, and I love you guys. We'll see you next time. if you're not having fun, start having some, because we are.